Hi, I'm Mike Moe with the training department here at Graco. Okay, today we're going to talk about the AODD. This is an electric diaphragm pump, and we're going to do this in two segments. The first one, we're going to talk about the operation, and the second segment, we're going to talk about how this pump stalls. Historically, pneumatic diaphragm pumps stall under pressure, and that's what makes them very unique. All right, electric motors typically won't stall under pressure, but this one will, and I want to show an example of how we do that. All right, so the first thing I want to talk about, though, is if you look at the actual fluid section of the diaphragm pump, it's the same as any diaphragm pump. We have two diaphragms, two fluid cavities. As the diaphragm is being pulled out of the cavity, it creates a low pressure zone, which allows the pump to load. And then as the diaphragm goes back into the cavity, it creates pressure, forcing the fluid out. All right, so nothing's changed on the fluid side of this diaphragm pump. All right, now let's take a look at the inner workings of the diaphragm pump. Okay, a couple of things I want to call attention to. The first thing is we've got this eccentric cam in the middle, and that's what's creating or giving that rotational movement a linear movement. All right. The other thing I want to point out is on the interior here, we have in green pressurized air. So you do have to pressurize the center cavity of this diaphragm pump. Okay, and we're going to talk a little bit about how you pressurize it and what the different pressures mean as we're going through here. But right now, this whole area here does have an air charge on it. All right, as this eccentric cam is going around, we're going to stop this animation right in the middle. That's perfect. So basically what's happening is as this roller is coming around, it's forcing this center carriage over. All right, when it's doing that, this little pin right here, or the diaphragm shaft, is in contact with this carriage. So as this carriage is moving over, it's actually pulling that diaphragm back. All right, this compressed air in here that I talked about, it's actually putting pressure on the back side of this diaphragm and causing this diaphragm to push into the cavity. All right, so there's two things going on. We've got the rotational cam that's pulling one diaphragm and the internal air pressure that's pushing the other. All right, we're going to start this back up again, and then we're going to talk about exactly how that compressed air is working in there. You want that compressed air to be slightly higher than the fluid section. All right, if that compressed air is too low, basically this pump will stall out because there's nothing behind that diaphragm, the second diaphragm, to push it over. All right, if it's too high, basically the pump starts working like any traditional diaphragm pump where there's very high pulsation on changeovers. So as long as that compressed air behind those diaphragms is slightly higher than the fluid pressure, the fluid stream or the fluid flow out of this pump is going to be very consistent and smooth. So basically, again, all that's going on is this cam right here on the eccentric shaft is rolling around, causing this carriage to move in a linear fashion. It's pulling one diaphragm, and the compressed air in this cavity right here is pushing the other diaphragm. Okay, in this second segment, we're going to talk about how this pump stalls under pressure. All right. So in the first segment, we talked about the operation and the fact that this carriage is moving back and forth, and it's pulling one diaphragm and the compressed air is pushing the other. All right. When fluid is shut off, in other words, on the outlet up here, when that is shut off and the fluid has no place to go, there's going to be an increase in pressure in the fluid section. And as soon as that increase in pressure on the fluid side exceeds the pressure behind the diaphragm, that creates the stall. All right. We discussed in the last segment that these diaphragm pins are connected to the diaphragms and they lead into this linear carriage, all right? But those pins are not secured to that linear carriage. In other words, they're free floating in there, okay? So what we're going to do is we're going to go ahead and we're going to start this animation, and then we're going to stall it out. And what you saw there is the arrows kind of got big, indicating that the pressure grew, all right? And now what you're seeing is as this carriage is moving back and forth, because the fluid is locked in on this side, the diaphragms stop moving, and then the carriage starts sliding across this pin. All right? So we're just going to run that through one more time, and we're going to increase that pressure. It's going to stall out, and now this carriage right here is just sliding back across these two pins.